So we're going to kind of continue what we did yesterday. So if you want, you can just add on to the notes from yesterday because it's kind of not... Not yet. Tomorrow we'll be doing the definite integrals. More in-definite integrals today, just to make sure we get the technique down, because definite integrals add one more step, and so I don't want to make it, I don't want to take a bite off more than we can chew. We're going to eat the elephant bit by bit, bite by bite, not trying to swallow the whole thing at once. Okay? TMI.
Hey, I watched this on Khan Academy.
This one?
No, not the same problem, but the topic.
Oh, okay.
What are you doing in free time
Wait.
to watch Khan Academy?
Well, I wasn't understanding it before when I did it, so I watched Khan Academy to get better.
Excellent use of your resources. Sorry?
Oh. White band, specifically.
I mean, I have, yes. I feel like I've seen the parody videos now I know that there's the original one. So anyway.
Do calculus. Come on, calculus.
Yes, that's right. Back on calculus. So no, you might find it surprising, but I only own a certain number of pairs of shoes, and I don't have white Vans or anything like that. So
White shoes are a staple in any man's wardrobe, Mr. Wade.
I guess I'm not a man then. All right. So
It's okay.
anyway, here we go. What should we do here? Ideas.
Integrate.
Okay, that's what we want to do. Integrate. How should we integrate?
Quickest way to piss off.
Any ideas about things we could do here to help us out?
Well,
I have no idea.
Ryan?
I'm just going to start off by saying it makes me much more comfortable when it's not a fraction. So I'm going to put all of the denominator into parentheses and put it to the negative 1.
Terrible idea.
All right, that might make things actually more complicated, I think, here. Let's say again. Make it to the 1/5 power. Okay, we can do that. Rewrite it here tomorrow. What about this 4? What can I do with a 4? We can. It's out front, right? It's the coefficients. We can rewrite as 4 integral 1 over x and then 6 plus ln x to the 1/5 power, right? Okay. But we're still...
That really does nothing for us.
Yeah, so, again, I kind of make this easier by putting it in the substitution note. So that means we're going to have a u here. So what should our u be?
I'm going to guess it's going to be 6 plus ln x.
Let's try 6 plus ln x. So let's let u equal 6 plus the natural log of x. All right.
Oh, I see how this is going to work out.
And so what is the derivative here? What would du be? Du is going to be what?
1 over x dx.
1 over x, okay, dx.
I like it.
Okay, do we have 1 over x dx in our problem?
Indeed, we do.
Yeah, it's right here, right there it is. Okay, and then there's dx, so it's going to directly substitute. Okay, so we still have 4 times the integral. Don't forget that 4, right? Very easy to do that because it's kind of like you're doing all this hard work over here in the integral, and there's that 4 that's just hanging out over there. Don't forget the 4. All right, very important. So, sorry, go ahead. In order to be able to do the substitution, it has to substitute. Everything needs to be able to be rewritten in terms of either u or du. If you can't get it to work that way, Emma, then you can't do the problem. It's impossible. So, if it's a problem that I'm giving to you and say, solve this, then yes, everything should convert to u and du, to answer your question, yeah. Okay, but there are certainly integrals that we'll find later on that we won't be able to do because we just don't have what we need to make a substitution. Anywho, so what does this substitute to be then?
1 over u to the 1/5 du.
There you go. 1 over u to the 1/5 du. Sometimes the book will sometimes you'll see it written this way, the du over u to the 1/5, because if I write 1 over u to the 1/5 du, well, that's a product, and so the du could go up in the numerator then and just say du over u to the 1/5. So sometimes you see it written this way, sometimes it's just 1 over u to the 1/5 du. So this is okay. We still can't quite integrate this as it's currently written. How do I need to further rewrite this?
I would write it as a negative exponent.
Yes, u to the negative 1/5 du, like so. Now we are ready to integrate that. Okay, now we're ready to integrate that. All right, and so let's see here. So, Emma, what's the integral of u to the negative 1/5? It's tricky because it's with fractions. When you integrate, what do you do with your exponents? You integrate something like u to a power, what do you do with that power?
Oh, 1/5.
Yeah, 4/5. And then exactly right, 5/4 out front, right? The reciprocal, okay, and then plus c there too. Okay, remember that 4 is multiplying by the entire integral there. So 4 multiplies to this term and 4 multiplies to the c, but again we know that c will just absorb the 4. And so what does this simplify to then, Emma? Plus c, good. And then our last step, 5 times 6 plus the natural log of x to the 4/5 plus c. Okay, there it is. Say again? You need to re-substitute back in terms of x.
So,
I don't know if it would be considered wrong or not. I don't know.
Wait, what did you say?
If you just left this as your final answer.
Yeah, because you already wrote that u equals 6 plus ln x.
I feel like that's the same thing as saying integral
Right.
of like d of t minus, yeah.
I'll say this though, example, multiple choice.
Yeah.
You'll see this, not this.
Yeah.
Okay,
So, like,
so
on a
you'll
free
need to be able to do that.
response.
But on like a free response, I think you might be okay just leaving it like that.
For your sake, would it be okay doing that?
Yes, but I don't think there will be a situation such that you'll stop here. There'll be like more work to do or something like that, which will require you to then plug back in. So, yeah, it's a kind of a moot point. Anyway, yeah, it's moo like a cow. It doesn't matter. It's moot.
I'm not sure what that.
That's from Friends, Joey.
Okay.
Anyway, that's like
Joey.
that's the only like Friends quote I ever remember. All right. He like describes what the word moot means, but he describes it as moo. Yeah, the point is moo. It's like a cow. It doesn't matter. It's moo. It means, oh, Joey.
Sounds like a science lesson.
Oh,
That's
Joey.
Friends quote.
All right, let's try this one here.
I looked over at Joey because I thought, never mind.
Yeah, if we were friends and.
No, the TV show Friends. Joey Tribbiani, a fictional character in a movie, in a TV show. All right, Christian.
Okay.
What do we do here? What do you want to let u equal? And it's okay to be wrong.
Dang, here goes low.
How about cosine squared of x?
Okay, cosine squared x. Let u equal cosine squared of x. So that'll leave our du to be what then?
Negative sine squared of x.
Careful, we have to use a chain rule here to take the derivative.
So
So it'll become what?
negative 2 sine.
So yeah, but okay, I see what you're saying. So it's going to be 2 cosine of x, because remember we have to bring the power out front, lower the power by 1, then times the derivative of what's inside, so it's going to be this.
Okay.
Right? You see that?
Yeah.
2 out front, yeah, it'll be 2 cosine x, negative sine x. So, now we do a substitution. The 3 we can pull out front. Let's see here. And we get u, and then, okay, so cosine squared gets replaced with u, but then we have to get our du in there, we have to like, we have the dx, we have a sine, but we have another cosine that we don't have to do the substitution. Do you see what I'm saying here? U is cosine squared, so that's replacing the cosine, but we have no other cosine for the du. So what does that mean?
Yeah.
The u is, yeah, we didn't choose right with the u. You chose poorly, but that's okay. Cosine x. You were close, Christian. You just want the cosine of x. Just want the cosine of x. It's part of the learning process, Maya. Okay. Let u equal cosine of x. Du is now what? Negative sine of x. Dx.
So wait, do you have to take that negative and put it out front of the integral?
Okay, so, right, I'm like, this is like really messy here, so let me go over here. So the 3 I'm going to leave out front. Right. We have cosine squared, so u is cosine squared, so it's u squared. Okay, so that takes care of the cosine, but then I have sine of x dx. My du here is listed as negative sine of x dx. So in order to match sine of x dx, what do I need to do to both sides of this little equation here? Yeah, multiply by negative 1 or divide by negative 1, whatever you want to say. We'll just flip the negative over and make it negative du equals positive sine of x dx. Now I can replace that sine x dx with this sine of x dx and make it negative du. So it's negative du, which then really is negative 3 integral u squared du, right? The negative in front can go out front with the 3, the coefficient there. All right, and the integral of u squared Brandon is
1/3 u prime, or I'll say 3 times 1/3 u prime plus
u cubed.
u cubed, sorry.
That's okay. I know. Think about transformers. I got it. Distribute 3, and we get negative u cubed plus c. Again, even though this is a negative 3 that we're distributing to that c, the c just kind of absorbs it, okay? If you want to make it negative u cubed minus c, that's okay, but plus c is also all right. Just like when you integrate with respect to dx, that disappears as well, right? It's the du also, it goes away. You're integrating, so it just disappears just like the dx does, okay? And it becomes then negative cosine of x cubed plus c, or if you really like to write it right, cosine cubed x plus c, like that. Easy, right?
Satisfying. Very satisfying.
Easy.
You like the word.
This is kind of like translation, right? We translate our integral from one language in terms of x. We translate it into another language in terms of u. This language is easier for us to understand, so we then do the work that we need to do, and then we retranslate it back, the answer back into the original language. Think of it that way, maybe.
That is a very abstract way to think about it.
Yes.
I like that.
Creativity. All right, here we go. So we had nice u substitution, we had not so nice u substitution, and then we have this thing called tricky u substitution. These designations, by the way, are made up. They are not real. So if you like go talk to an ABC student and you're like, yo, we just got to those tricky u substitutions, they were tough. It'll be like, tricky u substitution.
Dumber than they already think we are.
So right, exactly. So this is made up, okay? But it's tricky because you have to do a little like non-intuitive manipulation, like something like it's like, yeah.
What we got
Out there.
was that trick?
This was, I would say, not so nice u substitution. These, not so nice, because you had to. The not so nice ones involve you having to manipulate the du to make it like match. Let me show you this one. All right. The nice ones are like the u, when you pick it, the du is exactly there in the problem. You don't have to manipulate anything. Here we had to move the negative over. Here this one actually didn't have to be manipulated at all. So this one, I guess, was kind of like a nice u substitution, even though it wasn't that nice. But you get the idea. Okay. Okay. So again, this is a tricky u substitution. It's tricky. Okay. All right, so Joey, I am really addressing you this time. What would you say that you should be here? Using our kind of guidelines we've been using before, what would you say u equals?
2x minus 1.
There you go, and that's exactly right. So the way you choose the u is still similar to what we've done before. Okay, let u equal 2x minus 1, and so then that would result in du being 2 dx. Okay, right. Christian whispered, "That's a And it is a problem because when we go to look at our substitution here, we'll have the square root of u, and then instead of dx, I'll write a 2d, or instead of dx, I'll write 2, shoot, I need a 1/2, sorry, I might make a mistake here. I don't have dx, I don't have 2 dx, sorry, I just have 1 dx, right? For my du to sub in, I need a 2 dx, I only have a dx, so I multiply by 1/2 on both sides, and so now dx, I will sub in a 1/2 du. But you can still see a problem. We have this x in here. And it does not show up here in the dx at all, right? We need it, this should, ideally we want this to be 2x dx.
Can we solve for x relative to u?
So, and that's exactly right, okay? What we need to do here is we need to manipulate around our original our choice of u here. Since we decided that u is equal to 2x minus 1, that means u plus 1 equals 2x, right? If I add 1 to both sides, this is still true.
It's u plus 1 over 2.
And if I multiply by 1/2 on both sides, I get that x equals 1/2 u plus 1. Okay, so are we all okay with that? All I did was manipulate that original equation that we came up with to make it in terms of x. Why did I solve it for x? Because up here, I have an x that I need to rewrite in terms of u. I can't have x's mixed together with my u's. I want everything in terms of u. Well, this is the only x that I have left here, so I'll take this equation, solve it for x, and then I can re-plug in for u for the u's there. All right, so let's rewrite this then. So now this becomes then the integral, instead of x, it's 1/2 u plus 1 times u. And instead of square root of u, let's write that as u to the 1/2. And then the du. Oops, it's 1/2 du.
Do we need to simplify under the
Sorry.
integral?
Hang on. Okay, sorry, don't forget the 1/2 du there.
Do we need to simplify the integral more?
Oh yeah, yeah. Okay. So far so good. Any questions up to this point? I want to make sure I didn't lose anybody.
Did you cross out the first du?
What's that?
In like the far right one?
I made a mistake here. Instead of writing du, I was supposed to be a 1/2 du. I forgot to bring that 1/2 in. Sorry again?
I didn't know if there was 2 du.
Yeah, no, sorry.
Just make it 1/4.
Right, so let's go ahead, since these 1/2s, okay, are all being multiplied together, let's make that 1/4 and pull those out front since they're going to be just constants, or coefficients. So that leaves then u plus 1 times u to the 1/2 du. Okay? So, now what do we do?
Can you distribute?
Yes, we have to distribute. We can't integrate a product, so we have to distribute there. So it becomes u to the 3/2 plus u to the 1/2 du. Okay. And so Ryan, what is the integral of u to the 3/2?
3/5, so 2/5 u to the 5/2.
Okay, good. And what's the integral of u to the 1/2?
2/3 u to the 3.
Good. And then don't forget, right, we got to write that plus c. All right. So here's a case where, like I was saying before, we want to make sure this 1/4 distributes to every term here. Both of these terms get multiplied by that 1/4. And so it becomes, let's see here, 1/10 u to the 5/2 plus 1/6 u to the 3/2 plus c. I went ahead and simplified those fractions too. 1/4 times 2/5 is really 2/20ths, but that's 1/10. 1/4 times 2/3 is really 2/12ths. It's really 1/6. Oh no, I'm not done yet. And then our final step here. Replace the u with 2x minus 1. And there it is. Okay? It's tricky.
How many
Do we expect to be on like test or proof?
I'd say, 10 for any, I'm just kidding. You'd like to have one of these. Maybe two, you know what I mean? they're tough. And plus, there's so much other stuff we learn too. I can't give you a million of these because it would really take away from other
This
problems.
is like the upper end of integral.
Yeah, this is the upper end of U substitution. We
Okay.
still have a few more integrals that we're going to learn, but this is like the upper level, I would say, technique, the highest technique we're going to learn. Yes.
Okay.
Yeah, there's other stuff that ABBC students have to learn, but this is the highest level we're going to have to go to.
So we're done.
Ta-da.
Okay. All right, let's try another one.
I like it.
Let's try another.
10 per section? 55 or 60?
What happened to your pen?
This is the last one and it's out of ink. Still haven't gotten mine.
It's dead.
Yeah.
All right, we're only going to do one more of these, I think.
And then what? Assignment?
Yep.
Jeez. Quick day.
Yeah, it's pretty quick.
Is there gonna be a quiz on this?
What's your future?
You better believe it.
Do we have any more?
Ooh, in fact, that might be the only.
We don't have any more big grades before like midterm.
When is midterm?
Like tomorrow.
Yeah.
Midterms can't break.
Midterm's on tomorrow?
Yeah.
That's like term, midterm, that's right. Never mind. I was thinking mid-semester. I was like, boy, no way. Check my watch, like, what's today's date?
So that's the only tricky U substitution one I'm going to show you here, but I do want to show you, let's see, one other thing.
Can we do another one?
Yeah.
I don't know if let me see if I can come up with another one here. I don't know if I've got, let me see my previous examples. I just have that one there. Let me
pull up from the book here. Go down and go down.
Have you watched that music video?
No, I have not. I just heard the song in the radio. It's really catchy.
Yeah.
Midterm is gonna be 45 days. I don't think he realizes that a term is 45 days.
Did you know that each term goes back to... No, see, Connor, I understand what you're saying. I'm trying to say in 45 days.
No,
We
we're
are
not.
Yeah, that's what I was trying to say. That's what I was trying to say.
Oh, 45 days from now.
No, there's so many snow days, our last midterm is gonna be like 45 days.
Oh.
No, you didn't.
Connor, I understand what you're saying. I understand.
Alright, you're looking at me like that.
You get one, Mr. Witt?
I'm going to try and find one here. Let me see. What did I just do?
That would have been so much work.
Alright, we'll try this one. Okay, I have another one here.
Awesome.
I'm going to kind of make it up on my own, though, so beware. Uh-oh.
Does that mean it may or may not work?
Right, it may or may not work. And I got to plug in my computer.
Go down and go down. Hey, hey, Tech guys, do you know when that review starts? Yeah. I looked at the AP Psych class in the
Okay.
Why? Oh. Go down.
Alright, put that there. Sorry, I was going to get reorganized here. Okay, let's do one more here with you guys about that. Alright, so let's try another tricky U substitution.
These are so much better than the cash pens.
Alright. We're going off the rails here. We'll see how bad this ends up.
Did you write this off the spot?
No, I'm looking at one. I'm trying to manipulate it some, so we'll see how it works. I think it should work, but we'll see how crazy it gets. Okay. So again, part of the challenge with these problems is that, or not part of the challenge, but like part of the thing is I can't really mimic, you know, what it's like for you guys to be doing these problems in the wild and then to come across something like this. Because I'm already giving you the benefit of knowing that it's going to be a tricky U substitution, so you're already looking for it, which is good because you're kind of learning it right now anyway, so you need maybe that kind of like bridge to it. But remember, in the future, at some point, I'm just going to say, integrate this thing, and you'll have to decide, do I even need to use U substitution? If I use U substitution, is it going to be a tricky one, or is it just going to be like a normal way of doing it? If it's not U substitution, what other technique am I going to use? Maybe I just need to simplify it and not use U substitution. These are all things that you're going to have to be able to do in the wild, on a test, on a quiz, or what have you. So keep that in mind. Okay. This is not a good simulation of what a test or quiz is like. I'm already kind of like prompting you with what's going to happen next. So anyway. What should we let U equal here? 3x minus 2. All right, so then that yields du is simply what?
Oh, this is going to get messy, Mr. Wood.
3 dx. All right. So let's do our substitution here. I do not have a 3 dx. I just have dx. So what should I do with this 3? Divide it over, make it 1/3 du equals dx. And so now let's substitute in what we do have. I'm going to go ahead and pull that 1/3 out front, so I don't have to worry about it. Let's see, I still have an x in there that I haven't dealt with yet, and I've got the cube root of u du. All right, so far so good on that. Anyone, did I lose anyone at that point? We're all good there? All right, so again, x. I don't know what to do with this. My du here did not leave me with an x to cancel it out or substitute it out with, so I have to do something. So I'm going to manipulate this. Is that what you're going to say, Tom? Yeah, so we're going to manipulate this, solve this for x. So again, this is an equation. It's true because we said it's true, and it'll remain true throughout this entire problem. We've decided this is going to be so. And so if u is equal to 3x minus 2, that means u plus 2 is equal to 3x, and that means x is equal to 1/3 u plus 2/3. All right? We said this is true, so therefore this has to be true too. That's just using basic algebra, right? We said u is equal to 3x minus 2, so therefore this is going to have to be true as well. So I can rewrite this then as 1/3 times the integral of 1/3 u plus 2/3 all over. I'm going to rewrite cube root of u as u to the 1/3 du. You might be looking at that and say, did that really help? And it actually does. It actually does. Okay.
You need to take that other coefficient out.
We can eventually.
Okay.
Yeah, we can eventually.
So if I did that earlier, it shouldn't affect things.
Shouldn't. Okay. So, at this point, how can we go about simplifying this? Say it again?
You take out the coefficient. I guess bring up u to the 1/3.
Okay, so so you're saying make it u to the negative 1/3 times the quantity 1/3 u plus 2/3, like that? Is that what you meant? Bring it up? Yeah, okay. And now that we have it like this, what can we do? Distribute, right? Distribute. Okay, so that's 1/3 out front still. Okay, so u to the negative 1/3 times 1/3 u. U to the 2/3. 1/3 u to the 2/3, yep. Right, when you multiply, you add exponents. This is u to the 1, so negative 1/3 plus 1, 2/3. Okay, plus, well, the next one's easy. It's just going to be 2/3 u to the negative 1/3 du.
Pull out another 1/3.
Yeah, if you want to here, since both of these have like a 1/3, if you don't want to make these fractions, you can factor a 1/3 out of both these terms, and I get then 1/9 out front, u to the 2/3 plus 2u to the negative 1/3. Okay. And so, integrating here, u to the 2/3, Anna, what's going to be our new exponent for that, for this particular u when we integrate that? U to the 2/3 will become u to the what? So we're going to, well, we have to do something to the exponent first. Remember, we have to add 1 when we integrate. So it's really adding 3/3. So 5/3, and then the coefficient out front will be 3/5. That's right. Okay. Plus, and then what's going to be, what does u to the negative 1/3 become? Careful, we're adding a positive 3/3 to a negative 1/3. Yeah, write it off if you need to, that's fine. Yep, yeah, 2, and then 3 times 3 halves, u to the 2/3. Ugh. Maybe that way more complicated than I needed to. Whoops, no, I don't want to do it there. Yeah, so it'll be 3 u to the 2/3 if you simplify, yeah. So yeah, let me go ahead and just simplify that little step there. Alright, so it becomes, 3 u to the 2/3. Plus c. And you distribute the 1/9. So it becomes 3/45 u to the 5/3 plus 1/3 u to the 2/3 plus c. This is what happens when Mr. Wade makes up a problem. It gets yucky. Oh yeah, 1/15. So yeah, so 1/15 final substitution.
Wow, that was fun.
Fun in air quotes.
This isn't even the one probably done. So
You can see there's an art to writing some of these problems. I mean, you can't just like randomly pick numbers. Sometimes there's a definite art to it. You know, when I teach like Algebra 1, it's easier for me to like make up a problem where I know the equation's going to solve or it's going to give me a certain answer. When it's calculus stuff, it's just kind of like there's a lot more to consider. So you can still make a problem on the spot, but it's All right, so there's the final answer. Easy. Right, I have one more problem I want to look at. It's super quick, but it's not a U substitution, but it's just an example of how things sometimes you still have to like manipulate things. You have to get kind of creative with how you integrate. That's just this last one. The last problem, and then I'm going to give you guys your homework assignment. So.
It's like we're in the wild.
It's like we're finding it out of the wall.
That's right.
Okay, is it you, son?
That's right.
Underneath the bushes.
I'm gonna get
They're very deadly. Dangerous.
X plus X. That's a fun
E to the x plus x power.
You said this is not you, so?
You have to figure that out on you.
Well, I said it's not a tricky U substitution.
Oh, wait a minute.
But it is an example of just kind of a complicated derivative we should be able to do. Or integral we should be able to do. We can do this.
I like your hope. I like your hope.
Okay, so ideas here. I'll leave it open to the... What's that? So let U equal e to the x plus x? Let's try it.
I don't like that. That's how I know we're wrong.
You never know. Okay, e to the x, derivative of e to the x is e to the x. Derivative of x is 1, and so it's e to the x plus 1, like dx, like that. So, okay.
Oh, no, rip that. No.
Yeah, ripperonis, guys. Doesn't work. So what does this yield? So let me just show you here. What does this yield? So we said u is e to the x plus x. So that becomes then the integral of e to the u. But then we still have this, which does not exist there. So yeah, that's not right. That's not the right path to go. We shouldn't see, but that's okay. Sometimes we have to try something and then know that we need to turn around and try something else now. Sorry? Let u equal e to the x? Okay. So then du equals e to the x dx. And so this becomes integral of e to the u plus x, but then again, we need an e to the x here, and do we have an e to the x?
Is that what e to the value x is up there? The exponent is x.
It is.
Yeah.
So you're saying that this is the same thing as e to the x?
U0
Yeah.
no.
Times the exponent.
Would it not just
Is that
be,
the
would it not
same?
just be e to the x times e to the u?
Yes. Is that what you're going to say too, Christian? Yes. So when you add exponents, it's the same thing as multiplying, okay? Multiplying the bases together. We are so used to going the one direction. One direction. We are so used to going the one direction, that is multiplying to add the exponents, that we forget that we can also go in the opposite direction. When we're adding exponents, we can break that apart to a multiplication. And now, do we have what we need? Do we have what we need?
Yes, we do.
Yeah, look, e to the x dx. There it is. So what can replace that? What? Du. So this becomes just e to the u du. It's tricky. So it's e to the u plus c. So it's e to the x. Say again. E to the natural log of x would cancel, or natural, natural log of e to the x. E to the x. It's gonna get big really quick, really fast. Get big real fast. Okay, there it is. Voila. Questions on any of that? So the idea here is that just because we just learned U substitution, you should not forget the idea that sometimes you have to manipulate around your integrand before you can integrate it. Sometimes you have to manipulate the integrand before you can integrate it.
So, time doesn't relate, but like, the derivative of e has to be e to x. So, would the derivative of 2x be 2x?
Say 2 to the x, you're saying?
Yeah.
Okay, so the derivative of 2 to the x is... I'll talk about that here real quick. So, he's saying not 2x, he's saying 2 to the x, is what he's saying here.
I was
okay? Right. Because when you say derivative of 2x, that's, just 2. So anyway, okay. This, let's see, how do I want to say this? So, I think... It's like, I think it's natural log of 2 times 2 to the x, I believe is what it is. It's the derivative.
Well,
because
because ln of e,
Because the ln of e is just 1. So the derivative of 2 to the x is natural log of 2 times 2 to the x. Okay, that's the idea. That's what it is. So, or 3 to the x is natural log 3 times 3 to the x and stuff like that. Exactly. Yeah. But that's why it ends up being the way it is. Okay, folks.